Tonight, you will lose consciousness, become paralyzed, and enter a world that doesn't exist. You will have full conversations with people who aren't there. You will fly, fall, run from things that can't touch you, and feel emotions so real they follow you into the morning. And then you will wake up and call it sleep. But what is actually happening to your brain when you dream? And why, after millions of years of evolution, does your mind still do this every single night? The answer is far stranger than you think. Here is the first thing to know. You don't choose to dream. Your brain does it to you. Somewhere around 90 minutes after you fall asleep, a switch flips deep inside your brainstem. A cluster of neurons called the pons fires a signal upward. That signal travels through a structure called the thalamus and floods your visual cortex with activity. Your eyes begin moving rapidly beneath your eyelids. Your muscles go limp, and suddenly, you are somewhere else entirely. This is REM sleep, rapid eye movement sleep, and scientists have known about it since 1953, when a graduate student named Eugene Aserinsky noticed his sleeping son's eyes darting beneath closed lids and connected that movement to the most vivid phase of dreaming. Before that discovery, most researchers assumed sleep was a passive state, a period of brain rest, nothing happening, just darkness until morning. They were wrong. During REM sleep, your brain is almost as active as it is when you are fully awake. The prefrontal cortex, the part responsible for logic and self-awareness, goes quiet. But the emotional centers, the amygdala, the hippocampus, the visual cortex, they light up like a storm. You are not resting. You are running a different kind of program. One that has nothing to do with the world outside your body. So why? The question has haunted scientists, philosophers, and psychologists for centuries. Sigmund Freud believed dreams were a window into unconscious desires, the mind revealing what it could not say out loud during daylight. His theory dominated for decades. And then the data caught up. Freud was wrong about most of it. What replaced his theory was stranger and more interesting. In 2010, a researcher named Matthew Walker at the University of California, Berkeley began a series of experiments on sleep and memory. He wanted to know what REM sleep was actually doing. What he found reshaped everything. When people learned a new skill and then slept, they performed significantly better the next day. Not because rest had refreshed them, but because their sleeping brain had rehearsed the skill, replayed it, refined it, all without their knowledge. Your brain is practicing while you sleep, but it goes further than that. Walker's research showed that REM sleep does something else that almost no waking process can replicate. It strips the emotion from a memory while preserving the detail. Think about a time you experienced something painful, something that, in the immediate aftermath, felt overwhelming. A few weeks later, you could tell the story without falling apart. You remembered what happened, but the raw edge was gone. That is REM sleep doing its work. Every night your brain revisits the memories of the day and processes the emotional charge out of them. It keeps the lesson, it dissolves the pain. Without enough REM sleep, that process breaks down. Emotions that should have been processed stay raw. The volume stays turned up. Studies show that people deprived of REM sleep become more reactive, more emotionally unstable, more prone to anxiety. The world does not change, but their ability to process it does. Your dreams are not random noise, they are therapy, involuntary, unconscious, and free. But here is where it gets stranger. Neuroscientist Antti Revonsuo at the University of Turku in Finland proposed a theory in 2000 that most people have never heard of, even though it may explain why dreaming evolved in the first place. He called it the threat simulation theory. And the idea is exactly what it sounds like. Dreams exist to rehearse danger. Revonsuo analyzed the content of thousands of reported dreams and found a consistent pattern. Across cultures, across ages, across continents, human dreams skew negative. Threatening scenarios appear far more often than pleasant ones. You are being chased. You are falling. You are unprepared for something important. You are lost. Someone you love is in danger. These are not accidents. According to Revonsuo, they are the point. For most of human prehistory, the difference between life and death was your ability to react quickly to a threat. A predator, an enemy, a collapsing shelter, a fire. If your brain could simulate those threats while your body was safe, you could rehearse responses without dying in the process. You could run through scenarios, build mental maps of danger, sharpen your instincts while you slept. Your dreams may be the oldest training simulator in existence. Think about what that means for your nightmares. That falling sensation. The dream where you show up unprepared. The one where something is chasing you and you cannot run fast enough. Your ancestors ran that simulation too. Generation after generation, the brains that ran it more frequently survived more often. And those brains passed their dreaming patterns on to you. You are not just dreaming, you are inheriting a survival mechanism that is hundreds of thousands of years old. But your modern life is confusing that mechanism. There are no predators here, no collapsing shelters, no fires in the night. So the simulation runs anyway, pulls from the threats your current life offers. The exam you haven't studied for, the confrontation you're avoiding, the relationship that feels fragile, the deadline that is slipping. Your brain does not know the difference between a saber-toothed cat and a performance review. It treats them with the same machinery. That is why you dream about work, about failure, about things going wrong in slow motion while you stand there unable to move. Your ancient threat simulator is running on modern problems. There is one more layer to this, and it involves something even more unexpected. In 2019, a study published in the journal Science by Ingrid Kurtovich and her colleagues examined dream content across cultures and found evidence that the social dimension of dreaming is just as significant as the threat dimension. Humans dream about other people more than anything else. Relationships, hierarchies, alliances, betrayals, the social map of your life. And those dreams appear to help you navigate the real thing. Your brain is not just rehearsing physical survival, it is rehearsing your place in the group. Who trusts you? Who doesn't? What you said? What you should have said? How you would respond if everything fell apart? Every night, you are running thousands of social simulations, updating your model of the world and the people in it. This makes sense when you consider what killed ancient humans. It was rarely one predator at a time. It was social failure, exile from the group, betrayal, loss of alliance. A human alone in the wild was already dead. Your brain knew that, and it practiced for it. Every night, in the dark, while your body lay still. So what does that leave you with? It leaves you with this. Every dream you have ever had, every strange landscape, every impossible conversation, every moment of terror or flight or impossible physics was not random. It was not meaningless. It was your brain doing something ancient and deliberate, processing the day, rehearsing danger, navigating the people around you, filing what matters, releasing what doesn't. You have been doing this your whole life without knowing it. Tonight, when the light goes out and your eyes begin to move, your brain will not rest. It will go to work, running the old programs, practicing the old simulations, protecting you from threats you will never face in the exact forms you fear them. And in the morning, you will wake up and call it sleep. But now you know what it actually was.